Howdy calculates. Before we start today talking about fundamental theorem of calculus, you need to cross this out and change it. It is a big, fat typo, and it's very important that you change it. So fundamental theorem of calculus is nothing more than us finding the area under the curve, but now we're given boundaries, and notice that when I plug them in, the top one goes first and the bottom one goes second. Now, another thing to note here is I was starting with a function, and so when I go backwards and take the antiderivative, that gives me the capitals, versus if I started with first derivative and I go backwards, it just gives me the original function, which you're kind of used to. But that's the reason for using capitals, is if I started at the original function and I want to go backwards, then I sort of think of it as the mother function. And I know some of you are kind of cracking up that I just said that, but that's the way that I think of it. It'll help you remember, right? So notice down here when I plugged in, I did plug in the top first and the bottom second. So when I think about mean value theorem for integrals, this is really about finding the area or the approximate area, or maybe the average area, but it is an area. And so what it says is that there's some number sitting in the middle of my interval between A and B, so here it is, C, for whom its y value will actually give the correct area for under this curve. So now notice, if I chose that particular C and I plotted its y value, and I made my rectangle based off of that y value, well, keep in mind that I'd have a little bit too little on the left of f of c and a little bit too much on the right of f of c, and hopefully those would end up canceling each other out so that I get the actual area for the function. And so if you notice, this is nothing more than that y value f of c, and then imagine, so that's the height of the rectangle, and then b minus a, of course, would be my width of the rectangle. So I don't know exactly where that c is. It currently looks like I've drawn it at the midpoint, but it doesn't necessarily have to be the midpoint. It just says that there has to be some number in there that makes it magically work. And then think of the average value of a function really as nothing more than a y value. And if I take the mean value over here and I figure out, hey, here's the y value, f of c, and I'd like to get him by himself. So if I choose to do that, I could divide both sides by b minus a. And when I do, whoops, forgot the minus sign, I end up with this over here. So you'll notice all that's really happened is I've divided by b minus a, and consequently I would get this f of c character, who is nothing more than a y value, by himself. So they're tied together. So the mean value theorem is an area, the average value is a y value, and they're linked together. Okay, so on the next two, these are kind of special cases for the integrals for odd and even functions. Keep in mind that in order to determine if it's an odd function, if I plug in negative x, I get negative y. And for the even function, if I plug in negative x, I get positive y. And so if I have an example here for each one, if I use this example for the odd function, remember it's symmetric with respect to the origin, meaning I can do a 180-degree turn, versus this one, the even function is symmetric with respect to the y-axis, meaning I can fold over the y-axis and it lines up on top of itself.